Okay. So, hello everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 1D. Myself, Anshika Jain, and I will be moderating this session. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of this conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th of February 2004. And the virtual event is being held through the Zoom today and tomorrow, that is 21st and 22nd February 2024. And I hope you will enjoy the knowledgeable and interactive sessions throughout the day. So coming to the guidelines, in this session, we have 6 presentations and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. 12 minutes total for the presentation with 2 minutes for question and answer. And at 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remarks. If you have any query or any updates, you can write it to me in the chat box. Just before we get started with the session, I would like to introduce you all to the session chairs. So, first we have Dr. Afzal Abdul Kader. He has been working in several companies that provide system solutions in telecommunication and radio frequency identification in Malaysia, Singapore, and Indonesia. He joined the Islamic University of Rau, Indonesia, as a lecturer at Department of Informatics Engineering since 2015 to continue his research related to the wireless and mobile communication, sensing systems, computer and networking, VSN, and IoT. In 2019, he have promoted as an associate professor in informatics engineering, Faculty of Engineering, Islamic University of Rau, Indonesia. Welcome to the session, sir. You can share your quick welcome remarks with us. Sir, am I audible to you?
Yes, yes. Thank you, Anshika, for the introducing me. Yes, good afternoon from Indonesia and good morning from London. Welcome to the ICICT 2024, and thank you for the committee to inviting me as a session chair for this session. Thank you.
Thank you so much, sir. I'll also like to introduce you to our next session chair, that is Dr. Durgesh Mishra. Presently, he has been working as a director and professor, Symbiosis University of Applied Science, Indore, India. He's also a visiting faculty at IIT Indore, MP, India. He has 24 years of teaching experience and 10 years of research experience. He has published more than 90 papers in referred journals and conferences, including IEEE and ACM conferences. Welcome to the conference, sir. Can you please share the quick welcome remarks with us?
Yes, thank you, Anshika, for very good introductions, and I hope that, and then good afternoon to everybody, and our session chair Dr. Abdul, good afternoon, and all the participants. We are having the 4 papers. I think we have already, Anshika is given the that the 10 minutes of the presentation and 2 minutes for the question sessions.
So it's 12 minutes for the presentation, in which 10 minutes I'll raise a gentle reminder.
Right.
So,
Yes. So, with the best of luck to the all presenter, please go ahead.
Thank you so much, sir. Now we will be starting with the papers. So I want Camila to present her paper on different processes for graphical recognition of derivative of a function and eye tracker analysis. Camila, can you hear me? You may please start with your presentation. Yeah.
Yes, I cannot share my I cannot share
You
my
can
screen. Please.
Okay, I'll look into it. Nee, I've stopped sharing mine. Can you share now?
Okay. So,
Okay.
do you see in full screen?
Uh,
Yes,
yes,
yes.
ma'am. Yes, ma'am. I can see you.
Perfect.
See you.
So
Yeah.
I start. Good morning, everybody. I'm Spagnolo from Italy. I'm a researcher at University of Ferrara. Today, I'm going to present you a qualitative study on data collected by an eye tracker tool regarding a calculus task. In recent year, there has been an increase in the use of eye tracking tools for research in field of mathematics education. This technique used also in other fields such as psychology, neuroscience, or linguistics, as well as about cognitive process creativity, provides information about the way a person looks at a visual stimulus. Thanks to the eye tracker tool, it is possible to analyze the eye movement of a person while performing a mathematical task. So the way to read the text offers a lot of information about the problem-solving process. We focus attention on the problem-solving process of a calculus task involving the concept of derivative, and task chosen was a part of the international surveys Teams Advanced. In addition, the aim of the analysis is to highlight the difference between the gaze of experts and in mathematics, and that of non-experts in mathematics. The expert group is composed of high school teachers, PhDs, and academics, and the non-expert group is composed of students of scientific faculties who attended a calculus course in the first academic year. Moreover, we wish to observe what has changed since taking the calculus course. So there is 3 questions, research questions, and we predict that the observational approach of the expert and non-expert is different. We think the expert viewpoint focused most on the angular coefficient in the line equation. Instead, we believe that non-expert look mostly at the area of the graph where the line meets the curve and the ordinate of the tangent point. So, the subject of this research were students of the scientific course, as already I told you. For example, chemistry, engineering, physics, or first years of mathematics and mathematics graduates, PhD students, or high school teachers of mathematics. And this is, in this study, we use this instrument of eye tracker, so Toby Lab. These values of precision and accuracy were necessary to obtain the heat map and the gaze plot. In particular, the heat map is a graph in which the most interesting areas are represented with a warm color. These areas were observed for many times or for a long time, and this is most from the gaze. The gaze provides information about the trajectory of the eye movement on the screen. Used to represent time spent watching the visual stimulus. The eye tracker instrument was calibrated for each subject. Then candidates given a calculus task on the concept of derivatives with no time limit to solve it. Candidates read the text of the task on a monitor where an eye tracker camera was placed. Afterward, candidates were subjected to an interview to understand the problem-solving process chosen. In addition, during the interview of the subject, the task was shown to them again to detect and record the eye movement during these days. So this is one of the tasks, and this task in particular is included in Teams Advanced survey of 2008. Then, in the first macro-analysis, it is possible to divide candidates into three categories. In the first categories, there are candidates who prefer to focus their attention on the text of the question, and they almost completely ignore the task. In the second category, there are candidates who read the text quickly and after spending more time on the graph, try to solve the task through the graph information. And in the third category, there are candidates who favor neither the graph or the text. The eye movement of individual move better text and graph quick and with quick. We call this category type TG. So in the micro level of analysis of this category, we try to highlight the distribution of expert and non-expert, and it is possible to observe that the expert candidates belong to the first category, and in contrast, the non-expert candidates are supervised in category TNE, TGNE, and GNE. This is an example. So the heat map in the figures show that the fixation of the expert candidates focus on those parts of the text connected with the angular coefficient. In fact, these parts are sufficient to solve the task, and these fixations are linked to the cognitive process of the expert candidate who does not perform a mental calculation. This result is confirmed by the interviews. It is possible to say that the experts see the task's graphic register as a confirmational element. In contrast, we can see in this example that non-expert candidates focus their attention mainly on the graphical part of the task, and we have an opposite approach from TE candidates. As the data shows some saccades between the line equation in the textual part and tangency point in the graph part, and they try to use the knowledge of the coefficient and angular coefficient obtained in the textual part to find a connection with the graphical element in order to enact a cognitive process to solve the problem. So this is the conclusion. This work is a part of more general project which sets out to analyze by means of the eye tracker tool the data obtained from the administration of the questions based on concept learned in a standard calculus course. The basic idea is that by comparing the data obtained, it's possible to reconstruct the different approach and cognitive paths used to tackle a mathematical problem. The purpose is double. So on one hand, it is possible to take a snapshot of the delicate transition that the student faces in moving from a secondary school to university. On the other hand, it is possible to try to derive useful indication to improve the teaching of mathematics in first year of the university course. Also, we believe that this information also will be helpful from teacher professional development perspective. So thank you very much. And this is our emails. Thank you.
Yes, Camilla, I have one question.
Thank you.
Are you able to listen me? Am I
Yes.
audible? Yeah. Camilla, this is you have divided this micro level analysis and the analysis of type T, type G, type TG. And what's the parameters behind that, and why this is so, not the other parameters?
And why it's?
Why this type of parameters you have taken, not taken the other parameters also with influence this type of analysis?
Yes, we try to construct categories basing of the output of expert and non-expert. So in general, we decide to use a constructed grounded theory to take the categories and which was these four. Thank you.
Thank you.
Thank you so much, ma'am. Thank you so much. So next, we have N. Bhakti to present his paper titled Game Theme Prediction for smart mobile online educational games. Can you hear me, sir? Sir, can you hear me?
Yes, but this back tea is not available, I think so.
Yeah, let me see.
Okay, Anshika, if it's not
So we
available,
can,
you can go ahead for
yeah,
the next
yeah.
ones.
So
my
we have
screen.
the next
Okay,
person.
yeah.
Okay,
Can
okay.
hear me? I'm
Yeah,
here.
sir. Yeah, sir, we can hear you. Are you there?
Yeah,
Okay,
correct.
sir.
I'm here.
You can start with your presentation, sir.
Yeah, okay. Thanks, uh, and Shika and
Yeah.
Harsh. Okay, let me share my screen first. Can you all see my screen?
Yes, sir, we can.
Okay. Okay, good morning, everyone here in room D. Welcome to ICICT 2024 conference. My name is Eng Bati. All right. My co-author is Dr. Insu Song. Actually, I'm a PhD student, final year at James Cook University. So this is my second conference that I participated in. Okay, without much ado, the title of my presentation is Game Team Prediction for Smart Mobile Online Educational Games. So the following will be the contents of this presentation. I will take you through introduction, background, problems, then look at the methodology adopted, the kind of data collected, and some models of AI that were used for prediction. Then we look at results and finally deliver the conclusion. Now, as you all know, mobile education games were designed to help people learn information, acquire information of subjects like English, mathematics, geography, and so on. Also, we can actually use them to reinforce concepts to expand our knowledge. And as you all know, during the last pandemic, actually a lot of schools and institutions were closed. So what happens is that students have to migrate to the online platform. Online education games therefore proved to be an alternative learning platform during last pandemic, as mentioned by Cruz Cup. But as you all know, today, the current mobile educational game is built with a very random theme and game type. Random in the sense that every designer of a game has their own theme, has their own game type that they wish to use for education. So for example, if they teach a geography, person A may choose this theme and this game type. Person B may choose another game theme, another game type. So actually it's very random at the moment. But as you all know, game theme, game type can contribute to an immersive experience for game players, as mentioned by Bittencourt and Hinz. So therefore, the aim of this study is to explore game theme, game type for mobile educational games with the use of AI to bring about better learning experience and outcome. Now, this study is quite wide-ranging. So therefore, they are divided into 3 stages. The first stage is game theme, then we go on to game type, and finally we just evaluate the AI model to see how good it is in predicting the theme and game for learning content. just take you back to some background. When we say game team, we refers to use of a certain subject, certain scenario environment to immerse players. So usually the game team, you can feel through the game art, and the material components produced. For example, like the dialogue box, the score sheets, the buttons that you see in the background. Okay, so this will you feel the game team through all these components. And when we talk about AI, which is so wide ranging at the moment, for education, these are the current applications. We have intelligent tutoring system used by teachers to provide a tutor for students. And of course, the other one we all know is that a lot of administrative tasks of teachers, educators, can be done by using AI, which is already now being exploited. Okay, so teachers, educators can use the AI systems to mark, to grade subjects. Okay, and which are all along has been very monotonous, and now at least we have AI systems helping the educators. Then of course we have smart content, which is quite a good use of AI, where the textbook contents become more comprehensible, easy to navigate with summaries, flashcards, and practical tests. So these are examples of different themes that you can expect in games. So for this study, we actually employ 5 popular themes. As you can see, like battle royale, economic, environment sustainability, we have manga, we have space, or so-called the science fiction, we have sports, you can see a stadium. Okay, so these are popular themes being used in this study, because when you talk about game teams, there's a lot of teams in the whole landscape. Let's now look at the problems that this study attempt to answer. Okay, so as you all know, at the moment now, we may not know what game team can be used to teach mathematics for primary school students, or what game type can be used to teach English for secondary students. So at the moment, game designers design games using their own choices of game teams and type. So therefore, this study was initiated to look at game teams and game types. And therefore, we adopted this methodology where we start to produce 2D mobile educational games using our Copo system. Copo is actually a web-based software system. And then we have to produce enough games to be used for data collection. So we produce about 250 games. And in order to enable data collection, we actually use 250 business undergraduates at the Indonesian University to help us to answer questionnaires, to play the games. And then with the details, we then go on to learning experience, outcome computation. And with the data, we are able then to build a model, the AI model, and then we test the model to check that we can predict game team to employ for each subject lesson rendered in the mobile educational game. So this example of a learning content document. So when we produce the game, we have to resort to learning content. So this is a usual content document that every teachers, educators will have to use as they teach a subject. So for example, what's the title? which subject, category, what's the objective, very important, okay? And then synopsis, and maybe in this lesson, there's a certain question they want to address, okay? And then a certain activity that you want to address for this particular lesson. And the web software we use to, which is called nickname Copo, the architecture is shown here. It may look so a bit complicated, but it's not really. If you look at it, that in Copo, we can actually enter our content through journeys, and then we have the graphics which show the team. We can create the teams, and then we also have the application code. So these three are combined together, and the generator in Copo will generate the game, and the player therefore can play the game. Now, what's changed here with the team prediction is that we bring in AI. AI is a module here, and before the team and game is passed to the generator to generate, we will bring AI to predict the team and the game, so that the generator then generate the proper game with the proper team and game for this particular lesson. So this is an enhancement.
Sorry to interrupt, but dear
Yeah.
sir, you have 2 minutes to conclude the presentation.
Okay. So for data collection, this is the data set for our study, and you can see that there are 29 features, the exact and the target features to predict the team. And the team actually is the 5 popular teams from our research, and things like Battle Royale, environment, sustainability, manga, science fiction, and sports. So this problem that we have is a supervised machine problem. So therefore, we supervise machine learning here. And we start with the traditional machine models. So we make use of random forest, KNN, and decision tree. And these are the percentages that we found during testing. So we find that decision tree actually achieve very good accuracy in prediction. We also use transformer, things like bird classification model to process the data, and it has accuracy of 98%, which is close to decision tree. So I quickly move on to the results. I'll just give you a summary of the result because it can be very detailed. So here, the first thing we look at is that in this study, we actually have more female participants than male, slightly more, quite balanced. And most of them are in age group 21 to 23. They are doing foundation year of business degree course. And when we look at the participants, after playing the games, they have better than average learning experience. If you look at the 3 games, the post-game values here, so they have actually quite good results here. However, not too high percentage of participants have improved their game scores. We also find that there's no linear relationship between learning content, things like game team, lesson type, subject against learning experience score. Okay, learning experience score has more to do with the user experience quality criteria that the participants have chosen. On average, male participants award higher ratings than female participants for the scores. And the other thing is that different team used for mobile educational game can lead to different learning scores. And as you see just now, decision tree is the best model at this point for prediction of the game team. So in conclusion, I will say that this study contributes to current research because we bring AI to help us bring an informed choice of game team for the mobile educational game. And the other thing is that in using the lesson content, we have to describe very thoroughly each field so that the AI algorithm can process them. So as you all know, every study has its own limitation. So for this study, in future, we will want to have a more diverse group of participants from different education disciplines, not just business degree students. And also for game types or mechanics, we will try to use popular game mechanics of current time. Okay, because in this study, we just use a ordering mechanic only. And future research should look at creating an AI system to automate the generation of learning content and assets, which currently is manual. And also the process of generating mobile educational games can be more streamlined to match teachers' workflow and expectations. So with this, I've come to end my presentation. So thank you for your attention. If you have any question, you can actually email me or you can actually post a question after this point.
Yes, thank you, BT, for the presentation. So just now you saw the participants for this prediction. You mentioned male and female. Beside male and female, is it any other parameter indicator from the participant? For example, like
Yeah.
the school, the country, and how about the quantity? Yeah, thank you.
Yeah, it's actually about 250. The whole group is about 250, and it's quite balanced. It's just slightly half for male and slightly around halfway mark for males. It's quite balanced in that sense. And of course the age group and the course and yeah, from business degree, they are doing bachelor. And if you look at my
Thank you, sir.
yeah, these are the details. These are the
I think
demographics.
go for the next presentation.
Okay, thank you, BT. Yes, thank
Okay,
you.
thanks.
Thank you so much, sir, for your presentation. So can you please unshare the screen? Thank you, sir. So next up, we have Eric to present his paper titled Integrating White and Black Box Techniques for Interpretable Machine Learning. Are you there, sir?
Yes, can you hear me?
Yeah, I can hear you, sir. You may please start
Excellent.
the presentation.
Yes, sharing my screen right now. Can you see it, the slideshow? Perfect.
Yes, sir, we can see your presentation.
Great, thank you very much. My name is Eric. I'm a graduate student at Osaka Metropolitan University, and today I'm presenting our paper titled Integrating White and Black Box Techniques for Interpretable Machine Learning. So it's no secret that machine learning is everywhere in our daily lives, from medical diagnosis and treatment to online credit approval. But it's often very difficult to peek behind the curtain and understand why a decision was made by the machine learning model. So in this study, we propose a hybrid classifier design, which integrates low interpretable or black box with interpretable by design or white box methods. It's kind of a joke that modern machine learning is just a big combination of data and linear algebra, and you stir it together until the right answer comes out. But the reality is that balancing both the effectiveness and the interpretability of your machine learning model is quite a challenge. So for example, if we consider a decision tree, this is generally considered to be a highly interpretable method. If we have a shallow decision tree with maximum depth of 2, it does an okay job of explaining the data, and we can kind of, follow along what the decision tree is doing. If we increase the depth of the decision tree to 4, suddenly, even though this is still relatively shallow, it's going to take a little bit more work to parse through what exactly is going on, and the decision tree is, it's mostly accurate, but it's still making a lot of mistakes. And if we were to go one step further and we were to create a random forest containing 100 different decision trees all working together, we can see on the right-hand side here that now suddenly we're able to very accurately model our data, but a random forest of 100 decision trees, you've lost all sense of interpretability. So one way we can improve the accuracy of our models without necessarily increasing the complexity is by introducing what's called the reject option. Kind of famously buzzing around the internet, Microsoft Bing Copilot was very confidently confidently stating the results of the 2024 Super Bowl 2 hours before the game was even played. And so if we take this idea that not answering is often better than being confidently incorrect, we might want to allow our models to say, I don't know, or rejecting a given input instead of trying to make a guess. How we might approach this in classification is actually very simple. If we suppose we have like a binary classifier and it says the probability that classes y equals 1 is 95% and the probability that y equals 0 is 5%, then probably we can be very confident in that prediction. But alternatively, if the predictions or if the probabilities output by the classifier are 51% and 49%, then maybe we want to reject that input. And most algorithms for implementing the reject option use some form of numerical thresholding. And what this means is that usually we're going to be rejecting the area along the decision boundary. For example, this is just a Bayesian classifier. We can see that the thick dark line is the decision boundary. Anything within the shaded region is going to be rejected using the ideas on the previous slide. The problems with this, though, is that not every classification algorithm has some numerical output to threshold upon. And it's not necessarily intuitive why classification was rejected. For example, if you just say, oh, we didn't classify this pattern because it's near the decision boundary, that feels a little bit like a cop-out to me. So one previous study that our laboratory did was, instead of using a numerical threshold to implement the reject option, we trained a second classifier. And this can be any binary classification method that you'd like. And this classifier is going to take an input and it's going to output either accept or reject. And then if the output of that is accept, then we send it to the regular classifier that actually tries to predict y hat, and we output that. If the rejector, as we call it, outputs reject, then the final output is reject. And going with this approach, we've decoupled the idea of rejection from the decision boundary, and we've also lost the dependence on a numerical threshold. If you're going to actually implement the reject option, though, you have to consider what happens to rejected inputs. There's lots of research into this area, but currently the most common answer is still that you're going to manually label the patterns. And this can get very expensive very quickly. Additionally, certain applications are going to be ill-suited to that type of reject option. For example, if you have a virus scanner or a spam filter, you can't be sending every potentially spam email to a human to be manually labeling is this spam or not spam. And then lastly, if you want to achieve 100% accuracy or asymptotically close to 100% accuracy on your classification results, that means you're going to be rejecting a lot of inputs. So the goals of the study that we undertook for ICICT 2024 was to design a classification system which can classify all patterns, not rejecting any patterns, as accurately as possible while still using interpretable by design methods when possible. So our approach to accomplish this was to create a hybrid classifier where one side is a black box and one side is a white box, and divide the feature space into easy and hard regions. And what I mean by that is to take a step back and consider the two-stage reject option, which we had previously studied, And consider that this rejector, as we call it, that's outputting accept this pattern or reject this pattern, is really just a binary classifier that's outputting 0 or 1. And the linguistic terms are just arbitrary labels that we've stuck on top of it. And so really when it's saying accept, it means this pattern is fairly easy. And really when it's saying reject, it's saying, this pattern is very difficult to classify. We don't want to try to classify this and risk making a mistake. So this brings us to the proposed approach for this paper, which is a hybrid two-stage classifier, where patterns are either going to be considered easy or hard. And easy patterns, these are going to be very easy to classify. You can choose any interpretable method that supports classification and classify the easy patterns with that classifier. Alternatively, you will have a separate classifier that is trained without any concern for interpretability. You're just trying to have as accurate of a classifier as possible. And you would use that for the hard patterns. And within our paper, we call this the base classifier, because that's what you want to be using most of the time, and the deferral classifier, because you are deferring difficult patterns to that classifier. So training the system is actually fairly straightforward. You train your base and deferral classifiers. These are the multi-class classifiers, just as you normally would. And then to train the grader or the binary classifier, we relabel the training set. And we say, now that we've trained our base classifier, our decision tree, our rule-based classifier, if this is able to correctly classify this pattern, then we say this pattern is easy. If it's still not able to classify this pattern after we've trained it, then we say this pattern is hard. And then we use this relabeled data set to train the grader. The one kind of hiccup here is that if the base classifier is 90% accurate on the training set, then 90% of patterns are relabeled as easy, and this type of data set is highly imbalanced. It's a known problem to train from these. So what we do is we create synthetic examples of hard patterns. In our experiments, we use the SMOTE algorithm. So just kind of to work through an example, let's say we have this data set and we want to apply our method to it. The first thing we have to do is we have to train a interpretable method and a non-interpretable method. In this case, we have a decision tree on the left and a random forest classifier on the right. And then we need to divide the training examples into either easy or hard patterns based off of if the decision tree was able to correctly classify. And then since we can see on the left, we have like 6 hard patterns and a whole bunch of easy patterns, we need to synthetically create some more hard patterns so that we can actually train a binary classifier on this data set, which we do, and we get this output on the right. And so basically this is another decision tree, that's the grader, and anything within those solid lines is what we're going to be considering hard patterns, and anything outside of the lines is going to be an easy pattern. So now we get some new input, we get some input X, we're going to send it to the grader, and we're going to evaluate with the appropriate classifier. If the pattern lies within the non-shaded region, we would say it's easy, and we would use the decision tree on the left. And if it lies within the shaded region, we would say it's hard, and we would use the random forest classifier on the right. So how we actually evaluate this system, the 3 metrics we looked at for our paper is the accuracy of the base classifier, as just a simple accuracy. The final accuracy of the hybrid system, this is either going to be the output of the base or the deferral classifier, as determined by the difficulty of the input. And we evaluate this as a simple percentage as well. And then finally, we consider the deferral rate. This is the percentage of patterns considered hard by the grader and the percentage of patterns deferred to the deferral classifier. So for this, since we want to favor the interpretable methods when possible, we want this to be as low as possible. So in our computational experiments, we used 14 real-world data sets. We used a decision tree with a maximum depth of 4 as the base classifier. We used a random forest composed of 100 decision trees with no maximum depth as our deferral classifier, our non-interpretable example, and a decision tree with depth 4 as the grader. This is just a listing of all the data sets. We used a whole bunch of different shapes, sizes, number of classes, all of that. And just to look at a few of the results, on the breast cancer diagnostic data set, we can see that the decision tree was able to get 98% accuracy on the training set, and then combined into the hybrid system, we were able to get to 99.98% accuracy on the training set. And we can see on the left here, the deferral rate means that 9% of the patterns were classified by the random forest, and the remaining 91% were classified by the shallow decision tree. Unfortunately, the testing accuracy didn't really move much between what the decision tree was able to output on its own and what it was able to achieve when combined with the random forest. If we look at the gas sensor array drift dataset, though, we kind of can see a little bit of a different story where we see a huge jump in the training accuracy, but the testing accuracy also jumps from 73% to...
Sorry to interrupt, sir, but you have 2
Yes.
minutes to conclude your presentation.
Thank you very much. I am almost done. Thank you. And the testing accuracy jumps to 95%. And so this is kind of interesting to me because we can go from 73% accuracy on just the shallow decision tree, and then suddenly by sending 1/3 of the patterns to the random forest, we can get up to 95% accuracy on the testing data set. And then we have the spam-based data set, which is kind of in the middle, where we see a pretty big bump in the training accuracy, a medium bump in the testing accuracy, and we defer about 1/3 of the patterns as well. And these three data sets are kind of representative of the results across the whole 14. I have those available if anybody is interested. So how we're going to approach this in the future is we want to first understand what data characteristics are affecting the performance, as well as experiment with a greater variety of algorithms. A lot of this paper was kind of just a proof of concept, but there's a whole lot more types of white box and black box algorithms that we want to experiment with. And we also want to expand beyond classification. So in conclusion, we use a classifier to divide the feature space into easy and hard regions. Patterns within the easy region, we evaluate favoring interpretability. Hard patterns, we evaluate favoring accuracy. This allows us to balance classifier accuracy and interpretability. And finally, we really believe that this general framework is not necessarily limited to classification. And so we hope to experiment with problems such as regression or even unsupervised learning. That is my presentation. Thank you very much for your attention.
Thank you so much for your presentation, sir. Any questions?
Eric, can you tell me about something? Why this classification is fit for this problem?
What do you mean exactly?
Why this classification used to fit for this problem is for your problem? Is the classification is the right approach?
Do you mean for data sets or for
Yeah,
solving the... Yes. So the data sets we used are designed for classification problems. For example, the spam-based data set is a binary classification problem where you designate an email as spam or not spam.
Okay, email is spam. Okay. Right. Okay. Thank you.
Thank you so much, sir, for your presentation.
Thank you.
So next we have Fabian Santos to present his paper titled Leveraging Geographic Research, Web Applications and Surveys in the Construction of Educational Strategies in Ecuador. Sir, are you there?
Good morning. Thank you very much for the opportunity. Let me share my screen.
Yes,
Give
sure.
me a second. I can share it, please, if you allow me.
Yes, sir. Can you, you may start your presentation now.
Okay. Let me a second here. Okay. Can you let me know if you're looking my screen?
Sir. Yes, sir, it is visible.
Thank you very much. So let me start. I introduce myself. I am Fabian Santos. I am a researcher from the Universidad Indoamérica in my home city, Quito. And in behalf of the authors, the co-authors, sorry, I want to present you this paper titled Leveraging Geographic Research, Web Applications, and Surveys in the Construction of Educational Strategies in Ecuador. So this is my outline. First, I want to explain my background and motivation for this work. Then I'm going through the target geographical research. I want to communicate to stakeholders. So this is the next step on this talk. And finally, how I consolidate this knowledge in order to produce these strategies. So let's start with the background and motivation. I want to first say that Latin America socioeconomic disparities challenge SDG 4 basically because the access to quality education is complicated due to this fact. Second, I want to say that geographical research provides a broad view of these social issues, then communicate this type of research is essential for building knowledge and contribute educational policy building. So now I want to present to you the target geographical research titled, Urban Rural Gradients Predict Educational Gaps. It was published in the International Journal of Geoinformation. This was on 2021. And in summary, this research describes a machine learning approach for predict academic performance. It analyzed georeference data from higher education preparedness tests and surveys for students in Ecuador. It predicts exam scores based in a random forest and Boruta feature selection in order to identify influencing factors. In this map, you can see the high schools where the random forest classification model was produced for each of these high schools. And here you can see an example of the scores probabilities derived from this random forest. On the left side, you can see for the main cities in Ecuador, where the red colors means high probabilities for high test score, where the blue represent the contrary. On the right side, you can see an example of the influencing factors identified from the surveys derived from this data. So here is information about socioeconomic, vocational, and student home and high school environment that describe these influencing factors of these test scores. Now I want to show you how we proceed with the strategies to communicate this research to the stakeholders. That is the challenge of this work. So we applied three types of strategies. First was workshops with different stakeholders. The second was the conduction of different surveys. And finally, the construction of a web application to communicate the results of this research. Regarding the workshops and surveys, we contacted randomly 368 high schools, but we got response from 94 high schools for a 2-hour workshop in order to describe this research. The second strategy I mentioned was a mass mail email survey, which was sent to 3,284 high schools to collect data supporting the SDG for the strategies. On the left side, you can see an example of the questions we made on this survey. Basically, we ask about the government interaction, the web application performance, the factors explaining the exam scores, and the pandemic challenges and future emergencies approach that the high school stakeholders has. Regarding the web application, we constructed a dashboard that generates reports and graphs from the geographical research. It aggregates and reports spatial models from different influencing factors, thematics, and administrative levels. You can see on the figure on the left side the different buttons to aggregate the data, filter the data, and aggregate it. And you can see on these tabs on the number 4, where you can get the plots and the summary statistics from the models. So now I want to explain you how we consolidate the knowledge that we collected from 41 high school responses collected from the surveys. Basically, we got data from all the whole country. You can see in different colors here the surveys from different regions of Ecuador. And in summary, this survey result said that the challenges regarding these high scores and this exam were related to paid exam preparation, internet and tech limitation, student dropout, and teacher training. While regarding the pandemic, they said, the stakeholders said that it widened educational gaps. They proposed also some focus on rural areas, digital bridging, and teacher training on mental health. Finally, regarding the web application, we found that most users found the web application was useful with 77% positive response. Nevertheless, they also said that it lacked interactivity and depended on good internet connection. Here on the figure, you can see the ranking of the different thematics that these surveys shows that also were linked with our results on this geographical research. I want to show also the web application traffic that is important to understand what happened behind it. And basically, we found that workshops have high traffic, but we collected fewer surveys during that time, which was different when we sent the mass mailing, which have low traffic with the web application, but more surveys. It was a contrary behavior on these two stages on our research. So finally, I want to show you some conclusions about this work. One is we achieved a methodology for community engagement using geographical research, web application, and surveys. And despite its limitations, the approach facilitated reflection and enabled high school stakeholders to share perspectives on educational challenges. And finally, it enabled the formulation of 18 strategies for improving access to higher education and others in pandemic impact. This is part of the paper we put on the annex because it's a long table we want to share with government institutions. So that's all for this talk. I don't want to take too much time. So if you have questions, let me know, please. Thank you very much for your attention.
Yes, Fabian, thank you for the presentation. Just now you got response from the school that you get the survey from the web, the system. Is the response coming from the all over representing from the your country, Ecuador? Because my experience, some of the respondent only come from the a city town, because the rural area, because the connectivity and others, they don't have connectivity, then they don't respond. So our results is not representing all over cover for our entire. How about your case? Is the respondents any respondent from a rural area, city areas, suburban or urban, something like that?
Thank you very much for the question. Yes, when we decide which high schools we should contact, we prepare a sample where we try to contact with high schools in the rural area, on the urban area. We try to be a balanced number, but of course we have less attendance for the rural areas. But also we found that they have a low internet connection that difficult the interaction with them. So probably, as you said, this could be more or less biased to more urban areas. But when we make the survey, we try to differentiate also the urban and rural and get some results of what they prioritize as important factors to explain the test scores. In this regard, I think we try to use all the data possible, but of course this is a challenge when I said about communicating research.
Okay, thank you for your answer. That's all from me. Thank you.
Thank you to you.
Thank you so much, sir, for your presentation. Next
Thank you
up,
to you.
Next up, we have Mohammad Imran Nazir to present his paper on MNIST, handwritten digital recognition, using a deep learning based modified dual input convolutional neural network model. Sir, are you here?
Yes, thank you for giving me the opportunity. Am I audible to everyone?
Yes, sir, you are. Yes, sir, you are audible.
Yes, I'm sharing the screen. Thank you. Greetings, everyone. Before starting, I want to say Happy International Mother Language Day. Myself, Mohammad Imran Nazir. I'm a graduate student. I cannot start the video due to webcam limitation. You can obviously check out me from the right corner image. These things will be covered next in the upcoming presentation. Abstract. Machine learning and deep learning has came so far. For classifying mostly, ML and DL algorithms are commonly used for handwritten digit recognition. We propose a DI-CNN model which enhances the accuracy in digit recognition. The MNIST dataset includes 70,000 samples. We trained with these samples and got 99% accuracy. After that, we conducted a comparative analysis for our proposed model. Introduction. We all know about digits. In short, it's a unique symbol that represents number in mathematics. The difficulty arises detecting human written digits due to different writing styles. If you take a look into traditional ML algorithms, you will see they also fail to achieve satisfactory results due to complex nature of handwritten digits. Our key contribution is to design and implement DL-based dual input CNN model for recognition of the digits. Next, evaluate and comparison of the performance of our model with recent works on MNIST dataset by the previous researchers. Literature review. Nair and his co-authors trained with 3 different algorithms, XGBoost, gradient boosting, and AdaBoost, and their accuracy lied between 93 to 96%. Another study took a subset of NIST database and utilized machine learning techniques and found that LVM achieves 95% accuracy. Another researcher, Liu, combines learning approaches of mathematical fusion and CNN-based feature extraction and achieves over 98% accuracy. Next, Said and his co-authors found that by reducing correlation-based feature, K-star achieves 82% accuracy. Methodology. This is our system architecture. First, we have collected the dataset from Kaggle and pre-processed it. In this step, we did normalization to convert the images from 0 to 1. Then we fed the data into our proposed model, and after evaluation, we also predict some digits. Here is our proposed model. We used functional API instead of sequential API because it's more flexible and a powerful way to define models compared to sequential model. We have 3 convolution blocks having 6 convolers. We kept the pairing same so we don't lose any features. After each convolutional block, a max pooling layer is used to reduce the size in half for computational efficiency. Later, we concatenate both sides and pass to our neural network. And at last, we used softmax as it's a multi-class classification. Result analysis. Different models in the past has tried to acquire higher accuracy, and we performed well than others. The worst performance can be seen on decision tree classifier with just 74% accuracy, and our achieved accuracy is up to the mark. It's 98.9%. In the right side, a detailed comparison of our work is done with recall, F1 score, and precision. Next, here is the performance of individual digit in the dataset. We can see all digits performing excellent individually. Conclusion. We are able to develop a deep learning based model naming with dual input CNN model utilizing the MNIST datasets and different Python libraries. We evaluated the performance with different metrics. We believe we achieved higher accuracy, and we also acknowledge that there is need for further evaluation on mixed datasets as the performance may vary in such scenarios. Here are some references that are used in this presentation. Next, that's all from me today. Thank you so much for listening me patiently.
Thank you so much, sir. Are there any questions?
Yes,
Please.
I just a query about how the your system be able to recognize various pattern of the handwriting for digit recognition. Because some people write is not good enough, is something how your system be able, as you mentioned, the accuracy up to 98% just now.
Yes, I understand your question. The thing is that our dataset was having enough data. It's like 70,000. So those all were the handwritten digits written by other pupils. So we have trained our model with this. So I can say the accuracy will be perfect for any other check-ins.
One more thing.
Yes,
Have
please.
you test because writing, you are from Bangladesh, I'm from Indonesia, some from Korea or Japan. When
Yes.
they are writing like 1, 2, 3, 4 different background of characters may impact to the writings. Have you test from maybe all other background of the writings, so to prove that your models be able to recognize?
Yeah,
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 just
yeah.
suggestion. Yeah,
Yes,
thank
yes,
you.
I got it. Yes, it will be able to recognize because the NIST dataset is a international dataset which combines the handwritten digits from all other countries. So that will be the case because we have trained with all of these countries people's handwritten characters. Sorry, I mean digits. That's why it will be able to recognize it accurately.
Okay, thank you. That's all from me. Thank you.
Thank you so much.
Thank you so much, sir, for your presentation. Moving to the next presentation, we have Yoon A. Park to present her presentation on proxy re-encryption protocol in off-road emergency. Are you there, ma'am?
Yeah, I'm here.
Okay, you may start with your presentation then.
Yeah. Do you see my PPT material?
Yes, ma'am, we can.
Yeah, yes. Hello. I'm Hyuna Park from South Korea. I'm with Honam University as an assistant professor. Today, my topic is proxy encryption protocol in off-road emergency. This paper is about God. Sometimes accidents happen on road or off-road. In off-road accidents, we need drones to take photos of the areas cannot be accessed by regular vehicles. This time, data security becomes another hot issue and potential risks. As a solution, we provide the proxy encryption protocol for medical information in a far-edge environments. Mostly, proxy encryption uses a pairing function, but this function needs a heavy computational overheads. So we do not use the pairing function. Instead, we use RSA encryption. It is common used in the real world. What is proxy encryption? We assume three parties, sender Alice and recipient Bob, and in the middle, a proxy server. In our paper, the proxy server is a cloud server. First, Alice original message M with her public key. That is the first ciphertext CA. The CA is sent to proxy, and Alice gives the re-encryption key to proxy. Then the proxy re-encrypts the first encryption CA with the re-encryption key. Then Bob decrypts the re-encrypt ciphertext with re-encryption key, and he gets the original message M. It means that Bob can decrypt the original message M without knowing Alice's original encryption key. To make a cryptographic protocol, we assume application scenario. There are participants like this: smartphone S and the healthcare provider H, and emergency center E, and vehicle V, and the cloud server CS. CS is a semi-trusted party. And the drone and the control center CC. CC is a kind of TTP, trusted third party. So it controls all the things related to security. This is my application scenario. If an accident occurs, some citizens or drone reports that to CC control center. Then CC then CC makes an order to D and F for detail shot and first respond. Then the drone reports again for detail shot to CC. Based on the analysis, control center reorders to F, the first responder and the vehicle. The order includes the information nearby emergency center. In the meantime, CC generates the re-encryption keys, and then he sends the re-encryption key to CS and the emergency center. Then cloud server re-encrypts the first ciphertext. The first ciphertext is stored in originally by healthcare provider H's encryption key. So CS re-encrypts the first ciphertext with the re-encryption key, and then the re-encrypted ciphertext is sent to emergency center. Then emergency center can decrypt the received ciphertext with a re-encryption key. So emergency center can get the original medical history for the patients. Before going deeply, we need to check the security building blocks. The security assumption. We use RSA cryptography. Firstly, we have to select the key pairs. One is the public key E, and the other is private key D, like this. And the encryption key format is like this: M to the public key E, and the decryption format is ciphertext to the D. And we use another assumption, DLP. DLP means mathematical hard problem. It is difficult to or hard to find the integer x in this equation. DDH, 그러니까 decisional Diffie-Hellman, is also a mathematical hard problem. Given two triplets like this, it is difficult to distinguish AB equals C or not. We use also pseudo-random function and pseudo-random generator. In a word, it means that it is difficult to distinguish a real random or a pseudo-random. This slide shows the notation. F means pseudo-random function, exactly symmetric encryption function. And the D and E is the key pairs for public key system. The D is private key and E is public key. And R1, R2 is re-encryption keys, and S1 through S4 is decryption keys for encrypted messages. From this slide, it shows the whole protocol. After registration and authentication stage, we comes to accident stage. Until this slide, all the flows is communicated in plain text, and these numbers are matched to these numbers on the arrow. So each equation explain the numbers data flow. From this slide, all communication is encrypted, and until this, it's not so important. Just data flow is showed. From this slide, it is a little important. Number 5, CC start to set for the encryption keys. So CC generates random numbers alpha and gamma, and then computes these variables for the encryption. R1, R2 is for encryption, S1 through S4 for decryption. Then CC these values CC sent these values to CS and emergency center. CS received the encryption key from CS CC. So CS re-encrypts the first encryption ciphertext with the received re-encryption key. Then CS the re-encrypted ciphertext then CS sends the re-encrypted ciphertext to emergency center. Finally, emergency center decrypts the re-encrypted ciphertext with re-encryption key, like this, a little complicated. That's all. So security analysis. Our scheme is secure against CCA, that's chosen ciphertext attack, and our scheme is secure against a collusion attack. Additionally, our scheme is secure against proxy server forgery and man-in-the-middle attack. We evaluate the efficiency with the time complexity expressed big notation. So N represents the number of bits in a message M. Roughly, the overall computational complexity is O L to the 3. Conclusion. In this paper, we have proposed a security protocol much closer to cryptographic protocol that specify targets targets for medical information within finance environments. And we provide the method proxy encryption technology. It makes the recipient emergency center possible to get the original message without knowing the original encryption key, and makes the semi-trusted party the cloud server impossible know the original message. It means we can preventing cloud server from being an inner attacker. Oh, that's all. Do you have any question?
Yes, Park, I have a question. Your writing here is the make the semi-trusted party impossible to know, right? Then maybe possible.
Pardon? Pardon?
Are you able to hear me?
Pardon? Would you speak?
I am
Would you
Dr.
speak
Gurdeep
it again?
Mishra. Yes, yes,
Yeah.
yes. Yes. You told that the semi-trusted party that is impossible know that the original message, right? If there is a trusted party will disclose the data, then how you can protect?
Here, semi-trust party is the cloud server, and the cloud server stores and keep the first ciphertext. The ciphertext is encrypted with the healthcare providers' security key, and only except for CC, anyone cannot know the its participants the security key. And 그 cloud server re-encrypts the first ciphertext with the re-encryption key. Re-encryption key is also method made by CC. So the semi-trusted party, cloud server only stores the ciphertext.
But
They cannot
you use
decrypt anything.
Yeah, but you used RSA algorithm, but RSA algorithm is easily decrypted by the others.
RSA algorithm is used in the first encryption method.
Okay.
From the second encryption, we don't use RSA. Just I design algorithm that is re-encryption method.
Okay, thank you, thank you.
Thank you.
Thank you from my side.
Thank you so much, ma'am, for your presentation.
Thank you.
I would like to sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being the part of this international conference. I hope the session was interactive and informative enough for you. We, on the behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates emails within 2 working days. So further, all the papers have been already forwarded to the Springer. The publication will be live in the 6 months. So kindly cooperate with the team of ICICT 2024. And with that, I would also like to thank our session chair, Dr. Evizul Abdul Kader, for chairing this session. And this is a token of appreciation to our chair on the behalf of the whole team of ICICT 2024 and Global Knowledge Research Foundations. So would you like to share any closing remarks?
Yes, yes. Thank you, Ansika. Yes, again, thank you very much for the ICICT 2024 committee for inviting me as one of the session chair for this today's session. Thank you very much. Thank you for the participant and presenter for the present nice paperwork today. Thank you very much. Yes.
And I would also like to thank our session chair, Dr. Durgesh Mishra, for chairing this session. And so this is a token of appreciation on the behalf of the whole team of ICICT 2024 and Global Knowledge Research Foundation and partners. So would you like to share a closing remark?
Yeah. Thank you, Anshika, from the GR Foundations for inviting me as a session chair, and I was happy to see these 6 sessions of different authors. All they have presented their research work very nice way. I think they are working very hard, and this is a very good platform where we can discuss and to get their research work, accelerate their research works. Thank you. And thank you, Dr. Abdul, to join with us for sharing with the session chair with me. Thank you.
Thank you so
Thank
much,
you. Yeah.
everyone. Can you please, all of you, open your cameras for a quick snapshot? Yeah, I will be happy to see you all. So
Okay. Thank you, please.
thank you so much, everyone.
Thank you. Thank you. Thank you. Thank you.
Thank you for your valuable presence.
Thank you.